In assessment training practice number 4A, you really just need to remember the order of operations, and that will guide you to be successful in this. So order of operations, we do parentheses first, exponents, multiplying, dividing, whatever comes first, and then adding and subtracting. So we can't really do parentheses because if you notice in the first parenthesis, we have x squared and x. Those are not like terms, so we can't simplify. In the second parenthesis, we see an x squared and x, and then just a number, a constant. So those are not like terms either. We can't simplify exponents. However, we can multiply. So what's being multiplied right now is that negative 2x. Now, if you want to put the exponent of 1 to remember the exponent property of multiplying same bases, you add the exponents, please do so. So then we multiply the negative 2x times 2x squared, so that will get you a negative 4. X to the first times x squared, we add the exponents. And then we finish distributing. So negative 2 times negative 3 is a positive 6. X to the first times x to the first. Once again, we add the exponents. And then we have one more term. Negative 2 times 3 is negative 6. And then since that x has nothing to be multiplied with, we just bring it. Now notice I did not touch the first parenthesis. The reason why, there's just a positive 1 out in front, and that doesn't change anything. So what I recommend you doing is just dropping down exactly what you see. Now at this point, we have to remember our skills of combining like terms. Combining like terms is just a fancy way of saying adding or subtracting. So it's beneficial to you to put it in standard form. Standard form means highest exponent first. So I see an exponent of negative 4x to the third. So the exponent's actually the 3. There is no other exponent of 3 with x, so we're fine. The next one would be 4x squared plus 6x squared. 4 plus 6 is 10. Since we're combining like terms, we're not changing the identity of x squared, so you just rewrite it. And then lastly, negative 5x minus 6x. So negative 5 minus 6 is negative 11, and then we drop down the x. So then it's in standard form. There are no more like terms, so that is officially our answer. Now for number 2, whenever you see a problem like this, you always want to see what's inside the middle, what operation's happening, adding, subtracting, multiplying, or dividing. In this case, I didn't see a symbol, so I could just put a multiplication symbol, because when you have two parentheses touching each other like that, that means it's being multiplied. Now, some of you could use the strategy of foiling. However, I recommend using the area model. So we have a binomial times a binomial. So that means I'm going to make an area model a 2 by 2. It does not matter where you put the binomial. So you could put 3p minus 7 on the left, or you could put it on top like I did. Does not matter. And now area is multiplying the length times width. So 3 times 3 gets you that 9. Once again, I recommend putting the exponents because p times p, you have to add the exponents. Then we have 3 times negative 7 is negative 21. And then I have that p to the first power. And then you can do the bottom row. 4 times 3p is 12p. And then negative 7 times 4 is negative 28. Now, once you're in the area model, you can combine like terms. What I recommend doing is drawing that plus sign to remind you. And the only two items that are like terms is negative 21p and 12p. So since we want our answer to be in standard form, we do highest exponent first, which is the squared. So we have 9p squared. Negative 21 plus 12 is negative 9p. And then the negative 28 doesn't combine with anything. So that is our third term in our trinomial. Now, just like I told you in number 2, you want to look and see what's happening in the middle of the parentheses. So for number 2, you did not see an operation symbol. However, here we do. We see an adding. So this really means there's a positive 1 in front. And since it's a positive 1, that's not going to change the identity of the second parenthesis if you multiply. So what we recommend you do is just drop the parentheses. So that was a positive x squared, so that's why it's plus x squared, minus x plus 5. And now it becomes a problem like number 1. You want to find the highest exponent. So the highest exponent is a 2. And then we want to combine like terms. Feel free to put that 1 in front. So it's negative 3 plus 1. So that is negative 2x squared. Then you find the next highest exponent. So that is exponent of 1. So that is negative x, because that doesn't combine with anything. And then lastly, we have the 6. And then we have the plus 5. So that gets us plus 11. Now that is officially in standard form. Highest exponent down to the lowest exponent. Now for number 4, there's many different ways to do this problem. You can do distribution, you can do the area model. Whatever strategy gets the right answer, we are fine with. So I'll show both actually. I'm just going to put this 1 in front of the n, so you know that that's there. Then I'm going to distribute. Negative 2 times 1 is negative 2. N to the third times n squared. We're adding the exponent, so it's n to the 5th. Now be careful for this part. It's really a negative 3 times a negative 2. So that is going to get us a plus 6. N to the third times n. Add the exponents. So 3 plus 1 is 4. And then our last term to distribute, negative 2 times 4 is a negative 8. And then drop down that n to the third. Now, if you feel comfortable doing distribution, please do so. You can also treat this like the area model. We have one term by 3 terms. So there was a trinomial inside the parenthesis. Remember, tri means 3, nomial means terms. Once again, one of the biggest mistakes we see, students forget that negative sign with a 3, so just be careful. And then you can treat it like a problem like you did for number 2. So negative 2 n to the third times n to the second gets you negative 2 n to the 5th. Negative 2 n to the third times negative 3n gets you a positive 6n to the 4th. And then negative 2 times 4 gets you negative 8, and then that 9 to the third. Or I'm sorry, the n to the third. Now when you write the trinomial, make sure you do the operation symbols in between. So this was a positive 6n to the 4th, so that's really adding 6n to the 4th. And this is a negative, so it's really means subtraction. If you notice, it doesn't matter which strategy you get or which one you choose, your answer is going to be the same if you mathematically did it correctly. All right, number 5. Number 5 trips up students because of this square. Students want to distribute the square, which is not correct. The reason why you can't distribute is because of this symbol right here, the operation symbol, adding. You cannot distribute when there's more than one term in a parenthesis. So what we do in middle school and also in ninth grade, you learned that this number right here, the square, represents how many times the base repeats. Now in middle school, you just talked about 3 squared. So you would know 3 repeats 3 times. However, we've had to complicate things. So this is our entire base. So if we have 2a squared plus 4c to the third, and we see it squared, that means we have to rewrite it 2 times. Now, once again, just like problems under 2 and 3 and 4, we have to look what's in the middle. The middle shows multiplying. So when you see multiplying, you should automatically think area model. Now, even though there are 2 different letters, 2 different variables, don't let that throw you for a loop. Just remember your exponent rules and you'll be okay. So we have 2 times 2, which is 4. And notice that we have a squared times a squared. So we have the same base, so we can do a, and then we can add the exponents. 2 plus 2 is 4. Now for the second column, 2 times 4 is 8, but you have to be careful. We have a squared and we have c to the third. Those are 2 different variables. So what you do, you just rewrite them exactly how you see them in alphabetical order. Same thing with here. We do 4 times 2, which is 8, but we have a c to the third and a times 2. You can't multiply those together because they're not like variables. So what you do, you just join them and rewrite them. And then notice that I have both c to the thirds. We can finally do something with that. So 4 times 4 is 16. And since we have the same variable, same base, we're allowed to add the exponents. So c to the third times c to the third gets you c to the 6. Now, once again, we have to combine like terms because we have a squared and c to the third for both of our diagonal boxes. So we rewrite it for a to the 4th. 8 plus 8 is 16. And then we do not change the identity of a squared and c cubed plus 16c to the 6. Now I'm not going to do number 6, 7, 8, or 9 because those are very similar to the problems. Just for 9, be careful. It's a trinomial times a binomial. So you're going to have the area model represent 3 terms. And then part of it represent the 2 terms. So then you can just treat it like a problem that we did above. Same thing with number 10. Number 11, once again, you want to look what's happening in the middle. The middle is a negative. So that's really a -1 being distributed. -1 being distributed changes each sign to the opposite. So negative times negative gets you that positive 6x squared. -1 times 3x gets you that minus 3x. And then -1 times a positive 8 gets you a -8. And then we treat it just like a problem we did above, where we combine like terms. So highest exponent first. So positive 6x squared plus 2x squared gets you 8x squared. Negative 3x minus 3x gets you minus 6x. And then negative 3 minus 8 gets you minus 11. So number 12 is just the same. 13, I know it looks difficult because it's a diagram and students don't like diagrams, especially with a binomial for the length and then a monomial, one term for the width. But if you remember from first semester, we did perimeter equals 2L plus 2W. Well, if we make our top expression our length, and we make 3x be our width, all you have to do is substitute in. So we have P equals 2, and then whatever we had for our yellow, or for our length, which in this case I put the 2x plus 5, then plus 2, and then times our width, which is 3x. And then that's all you have to do. You don't have to simplify it. It just asks you to write an expression. In this case, I actually wrote an equation. So if they want an expression, you just write that. Or if you want an equation, perimeter equals, that's fine. Now, the area for a rectangle is area equals length times width. So all you have to do is write the length times the width. So we have 2x plus 5, and then you have 3x. Now for 14, it says a 65-inch television is named by the length of the diagonal of the TV. Since the angles of the TV are right angles, the Pythagorean theorem can be used to compare the dimensions to the diagonal. So this right here is the Pythagorean theorem. You should be all aware of that. It says rearrange the formula to solve for the height of A. So I recommend rewriting the equation. Now, what I have been telling my students, we want to circle the letter we're looking for, and we want to undo order of operations. So the first thing that we need to do, we need to undo adding or subtracting. So what is happening to our A? We have to take care of the adding b squared. So we take away b squared. So then we're left with a squared equals c squared minus b squared. So once again, circle the A. So we're done with that level. We have to ask ourselves, is there any multiplying or dividing happening to A? Which is no, it's being squared. So we have exponent. To undo squaring, it is the square root. Whatever you do to one side, you do to the other. That's an undo operation. So we are left with A equals the square root of c squared minus b squared. Now for 15, it says the gross profit rate P is calculated using the formula P equals S minus C divided by S, where S is the net sales and C is the cost of goods sold. Rearrange to find C. So there's many different ways to do this. One thing that I've noticed with my students, they want to attack the C first. They want to deal with it first, but you can't because there's something in the denominator. So you have to take care of the dividing by S. To undo dividing by S, we multiply by S. That takes care of the denominator. So then we have S times P equals S minus C. Once again, we're looking for C. So then we have to undo the adding S. So we take away S. So then we have SP minus S equals negative C. Now we still have that negative. That negative is really -1, so we can divide everything by -1. So then we have C equals SP divided by -1 is negative SP. Negative S divided by -1 is a plus S. So for 16 and 17, I'm going to let you try to do those on your own. You can ask your teacher to make sure that you are doing it correctly. Or you can leave a post on the blog if you want to see if you did it correctly as well. Thank you.